In this chapter, we're going to be focused specifically on slope and the rate of change. And we're going to start by reviewing fractions, ratios, and percentages. Okay, hi everyone. In this unit, we're going to be studying slope and the rate of change. Now, slope, okay, or this idea of rate of change, is an enormous idea in mathematics. It's huge. It shows up in all sorts of different areas, not just in math, in science as well. Later on in calculus, you're going to see that probably like calculus can be divided in half, and half of it is really to look at how we calculate slopes of different functions, different relations here. Now, moving into that, one of the first things we want to make sure that we're all comfortable with here are fractions, ratios, and percentages, because you're going to see how slope is related to that. Okay, so let's start off with fractions. Now, you know what a fraction is, but let's just make sure that we're all on the same page with this here. So a fraction is a number that represents one or more equal parts of a whole unit. Okay, so it's parts of a whole unit. And we usually write fractions in this way with a number over another number here. The number on top here, we call that our numerator. And what that numerator does is it tells us how many parts of the whole, okay, and it's really important that we catch that, of the whole that we have. Now, how many parts? Now, at this point here, I haven't told you what those parts are, okay? So we need to specify them. It's like me saying I've got a certain number of fruit, but I haven't told you what the fruit. The denominator is all about. Okay, that's that number at the bottom of the fraction, our denominator. This tells us what those parts of the whole are. Okay? So when you put those together, you might end up with a fraction like this, 2 over 5. Now, I want to give you guys a little bit of help here because I know that fractions are one of those things that a lot of people struggle with. Okay? And I think sometimes, and I might be wrong on this, but I think sometimes the reason why people struggle with this is because when you look at fractions here, oftentimes we're misinterpreting what's going on here, or we're thinking about them slightly incorrectly here. Now, if you focus on this as being 2 divided by 5, see, I think that's where you're going to get lost and you're going to miss out on kind of a more important point here. The better way to look at this is not just 2 over 5 or 2 divided by 5, but to think of this as 2 fifths. Okay? So what I've done is I've broken up the circle into 5 pieces. Okay, so that's what the denominator is telling us. It's telling us how many pieces the whole has been broken up into. And the numerator tells us how many of those we have. I have 2 fifths of the whole. Okay, and if people were to say it correctly here, I think it would make way more sense. In fact, I think of some of the operations that we do would make more sense to people, because you know that when you add fractions or subtract fractions, you have to find a common denominator. Okay, and that's because we're trying to add parts together, but I can't add parts together if they're not the same sized part. Anyway, we'll talk about stuff like that later on, but I think when people get caught up on this being a division, that's where we lose some of the clarity on this. We're trying to make this make sense for ourselves. We're trying to this as an operation, but it's far better to think of this as the numerator tells us how many of that denominator piece that we have. Okay, so I hope that helps a little bit. Anyway, let's keep going here. So we've got 2 different things that we need to look at here. We've got proper fractions and improper fractions, and essentially, if you've ever gone through this, I think you're probably familiar with this. A proper fraction are those where the top number, the numerator, okay, I'm going to say that again. The numerator is less than the bottom number or denominator. So what that really means is we are talking about a group of pieces of the whole, okay? But it's important to represent that this is going to be less than the whole unit. So the number of, or the size of the part, so here in this one we've broken, so this is a proper fraction here. We've broken up the whole into 5 pieces, and I don't even have 5 of them. Okay, I've only got 2 of those. I could have 3 of those, 4 of those. And in which case, what I've got here is the amount that I've got is less than the whole. Now, an improper fraction is where the top number here, the numerator, is greater than or equal to the bottom number, the denominator. And as soon as you do that, as soon as I've got 7/5, so I've taken that that whole there. Whoops. Oh, wow. I broke that into all sorts of stuff here. I don't know what made me do that. Let's do that again. Yikes. Okay. So if I've got 7 of them, that means I've got all 5 plus, okay, 2 more. So what I end up with here is something that's more than a whole unit, and that's an improper fraction. Now, a lot of times you'll see people that will write this and they'll convert this to a mixed fraction where they'll say, okay, that means we've got 1 and 2/5 there. There's places where that kind of notation is totally appropriate. There are other places where it's better to actually write it as an improper fraction, and that actually adds a little bit more clarity to it. So you need to be familiar with those. Now, simplifying fractions. In mathematics, we always want to leave our answer in the simplest possible form. Now, the reason for that is because when we do stuff with those answers here, we don't want to be... If we can take an expression and rewrite it in a form that's got smaller numbers, but it's still the same thing, that is a huge bonus for us. Okay, so with fractions, that means we want the smallest numbers possible. So to do so, we divide the top and bottom numbers by the same number until we no longer have a common divisor. Now, you're probably quite familiar with this. So for example, if we did something like this, let's say we had 8/16. Well, notice that there's a common factor of 4 in both of those numbers there, right? I can rewrite 8. It is possible to rewrite that as 2 times 4, and 16 is 4 times 4. Well, because of that common factor of 4, I have a little bit of freedom here. Sometimes this might be where people get confused with this in terms of the operations. I have a little bit of freedom here with the operations. If the operations are all multiple, this division, I can go 4 divided by 4 and get a 1 there. And what that leaves me with is 2/4. So 8/16 is exactly the same. Numbers are smaller. And you know what? 4 can be written as 2 times 2. And so once again, I can divide that out here. And remember, when I divide, I get 1. And we always put that in the numerator. And I get 1/2. So 8/16 is the same as 2/4, is the same as 1/2. Well, this is a far easier way to express that. At least it's easier for us to work with later on. Okay, so being able to simplify fractions is an important skill. Okay, so let's go through and do some examples of simplifying here. So for example, we start with 15/25. So what I want to do here is rewrite these in terms of factors. Okay, just split them apart. I'm not changing the numbers. I'm just rewriting the same number in a different way here. So for example, 15, I know I can write 15 as 3 times 5. And I know that I can write 25 as 5 times 5. Once I've written it like that, and I see that there's a 5 in the numerator, and I got a couple of 5s in the denominator, but I really just focus on 1. Remember, I can do some of these operations in a slightly different order. I can divide that 5 and that 5 out. 1 multiplied by 3/5 is just 3/5. These are both prime numbers. I can't split those up any further, so that's it. That's as far as that can go. Now, 28/16. Okay, well, maybe you look at these and you think, well, I don't know what to divide them by. I haven't got a clue. Well, okay, let's work with that. But I do know that they're both even, so I know that I can take and divide 28 by 2, and I would get 14. 16 divided by 2 is going to be 8. And then those 2's are going to cancel. I will divide 2 by 2. And so that would leave me with 14/8. Well, once again, I know that those are both even, so I can divide 14 by 2, I can divide 8 by 2, Oops. And then I can divide out those two. Well, now we run into a little bit of difficulty. And again, you might look at that and say, well, gee, I don't know. So let's just start small here. Those guys by 2. And the answer is no. No, I can't. Okay, so that actually leads me to think, well, maybe that is starting to look like it's in simplest form. But let's keep looking here. And what I want to do is I want to just kind of work my way up through specifically the prime numbers. And so, and if you're not sure at the beginning what those are here, the prime 2, 3, 5, 7, 11, 13, and so on. But usually you don't have to go much past them to achieve what we want you to achieve here. These are numbers that can't be broken down any further. They are the building blocks. So what I'm testing to see here is where I got to start pulling out these building blocks. Now, 2 doesn't work here. So let's try 3. 27 does divide by 3. 3 times 9 is 27. And then 81 is 3 times 27. Well, that's kind of an interesting thing to pop up there. But let's keep going here. So the 3's will cancel. And I'm left with 9 over 27. And then I try it again. Are they divisible by 2? No. Are they divisible by 3? 9 is 3 times 3. 27 is 3 times 9. The 3's will cancel here. And then I'm left with 3 over 9. Now, 3 is already a prime number, but 9 isn't. 9 is 3 times 3. Again, there's that common 3 top and bottom. And what that leaves me with, remember, when I do the division, I'm 3 divided by 3 is 1. Okay? That 3 down here, sometimes I see people will just leave this as a 3 there, but that's not true. That 3 is in the denominator. It doesn't automatically pop up. There's nothing that brings it up here. So that 3 stays in the denominator, and then that 3 divided by 3 becomes 1. And so that's what we're working with here. That 27 over 81 reduces down to 1/3. And when you take a look at what these guys are equivalent to, aren't these forms here that we just found, aren't they simpler to work with? They're simpler to even understand than these other ones here. 27 over 81, that is not clear to me. But 1/3 is. Okay? 1/3 is. It is far easier for me to get my head around 1/3 than it would be to think about what this looks like if I've chopped it up into 81 pieces and I only shaded in 27. It's not clear to me that that's equal to 1/3, but they are the same. And that number, this expression, is far easier to work with. Okay, now we want to take a look at ratios. And ratios are a way of comparing two numbers measured in the same units. Okay, and that's an important little point there here. Measured in the same units and expressed in fraction form, it would look something like this. We would write 17 over 9, or arithmetically 17 to 9, okay? Where the little colon there, we usually use the word 2. So 17 to 9 here, or 17 over 9. And again, the units are the same, so we don't typically put units down. Okay, we don't usually need to do that. So now, notice that the top number in the fraction, okay, the numerator, ends up being the first number in the ratio. Okay, it also represents the first group when we're talking about a word description here. So, just as an example here, slide up here, just so you see this. Let's say we're taking a look at a problem here where there are 7 journeymen welders and 2 apprentices working in a shop. So write the ratio of journeyman welders to apprentices as both a ratio and a fraction. Okay, well, because we stated the number of journeymen, or we mentioned the journeyman first, that is the value that's going to come first here. So what would happen here is we're going to write journeyman welders to apprentices as both a ratio and a fraction. So as a ratio here, it was going to be 7 to 2. And as a fraction, we would write that as 7 over 2. Okay, now slide down here a little bit. we've got another one here. It says, write the ratio of apprentices to journeyman welders as both a ratio and a fraction. Well, now that we've put the emphasis on apprentices, that's the number that's going to show up first. And so in this case, that would be 2 colon 7, so 2 to 7, or 2 over 7. And that's really all we got to do. All right, now let's take a moment or two here to just simplify some ratios here. Now, reducing ratios is the same as reducing fractions. And you could probably guess that because even if you look at the previous question that we just did here, there's two different ways of writing the same thing. So you would expect that they would both simplify in a similar sort of way there. So if we can divide both numbers by the same number, okay, so if they're both multiples of some common factor in there, then we can simplify by dividing that factor out of both of them. Okay, and then when there are no more, I should say, common divisors there, well, we're done. So let's simplify the following here. So take a look at 16 to 32 here. Well, 16, okay, immediately I might think of that as 2 times 8. And then look over here at 32. Well, 32 is going to be 4 times 8. Okay, that jumps out at me right away here. Well, notice that there's an 8 on both sides. Well, I can divide both sides by 8 here, then I'm left with 2 to 4. But take a look at this. There's a common factor of 2 on both sides because I know 4 can be written as 2 times 2. And so now there's this common 2. And so now I can cancel that out here and get 1 to 2. Which probably tells me that I could have jumped a little bit further than I did in my first step here. There is a common factor of 16 to both those numbers, and I could have jumped right to that right away. Here, 100 to 5. Well, I like having a 5 there, that prime number, because I can't reduce down that 5 any further. But the 100 I can, and because it is a factor, sorry, it is a multiple of 5 here. So 100 can be written as 20 multiplied by 5 to 5, and then I can divide both sides by that 5. Now remember, when I do that, and I divide both sides by 5, 5 divided by 5 is 1. So I'm just going to leave, this is going to become 20 to 1. And then over here, 3 to 52, let's take a quick look at 52. Well, 52 is divisible by 2. So 52 is going to be, go over here, this is going to be 2 multiplied by, what's that going to be? 26. Okay. 26 is divisible by 2. 13. Okay, see, what I'm looking for is the number 3. I like the fact that there's a 3 here because 3 is a prime number, which means that's as simple as that's going to get here. So I can't break 3 up anymore. So if I'm going to simplify this at all, it has to be because there's a 3 in that 52. And it turns out there isn't. So that is as simple as that particular ratio is going to get. Okay, in this next section here, we're going to take a quick look at percentages. So percentages are numbers that are expressed, that they're representative of fractions, but very specific type of fraction with a denominator of 100. Okay, and so that little symbol right there that we use here, that basically means out of 100. Okay, so when we talk about 60%, we mean 60 out of 100. So a percentage represents that portion out of the total. And it's just a convenient way of talking about that sort of thing, about that part of the whole. And we're very familiar with that. I mean, as you go through school, you're always seeing percentages. Okay? So it can be expressed as a whole number, and it's usually typically less than 100. It doesn't have to be. Okay? You can have percentages that are greater than 100, 200%, 300%, and so on. You can have whatever here. And it can be a decimal. But normally we're talking about just a whole number, and it's usually a number between 0 and 100. If you want to express a percentage as a decimal, you simply divide that number by 100, which really just means move the decimal 2 places to the left. Okay? So, for example, if you had, let's just say 65%, if I wanted to express that as a decimal here, I would simply move the decimal that's right here. Because remember, if you don't see the decimal, it's at the back of the number here. And then you just simply move it 2 forward. So it'd be 0.65 as a decimal. And that's exactly what that means. Okay? So to convert a decimal back to a percentage, you simply multiply by 100. So let's say I had 0.23. Well, I can convert that to a percentage by multiplying by 100, which basically means I'm going to take that decimal and I'm going to move it 2 spaces to the right. So 23, and then percent, so that I understand what this is. Okay, that's a fraction out of 100. And remember, when I'm looking at these decimals, I'm still communicating that idea of a fraction out of 100. This is based on where that final digit is. Bear in mind, this is 65 hundredths. This is 23 hundredths. Okay, because of the spot, the place value of that last digit. Now, if you want to calculate a percentage, this is what you would do here. Basically, you're going to have the thing is out of, right? However much you've got out of whatever the total is. So then you use cross multiplication and division to solve. So, for example, if I wanted to know what, let's say, what percentage 25 is, or let's make it something easier. Let's say 5 out of 20. Okay, what percentage is that? Well, what I would do here is essentially cross multiply. So here's my percent. This is my unknown right here. So 5 times 100, 500 is equal to 20 times that percentage. Okay, which is, again, this is the unknown thing that I'm looking for. And then I would simply divide. Okay, and if you divide here, okay, you'll get 500 divided by 20 is equal to that percentage that we're looking for here. Now, bear in mind, we're using that percentage as kind of a variable here. That's maybe not the best way to, maybe we should have said like X percent. So X times X percent. And when I divide that out here, I'm going to get, tens are going to cancel. 50 divided by 2 will be 25. So that will be 25 is that percentage, that X percent that we're looking for. That's how you would do that. Anyway, let's take a look at some questions. Okay, let's look at some questions. So, for example, what is 15% of 450? Well, so this is what it is out of. This is going to equal the percentage of 100 here. So 15 is going to go where the percentage is in this equation, since it has the percentage with it. So we're going to build our little cross multiple here. And actually, it's been done for you down here, so it's something that you can follow. So we're going to put the 15 up top over the 100, okay, because we're going to take that 15% basically and write it as that fraction that it implies here. Now, of 450, that is basically telling you where that number goes in this expression here when we do the cross multiplication. We want to know what the is part of that is up there out of 450. So we put the 450 where the of is. Okay? And then we're going to just cross multiply. So this is going to end up being 450 times 15. Okay? So I've just got my calculator over here. 450 times 15. When I cross multiply, and that's going to be 6,750, is going to equal 100 times x. Okay? Now remember what I'm looking for here. I want to know what the number is, okay, that when I divide it by 450, I get 15%. So now if you divide both sides by 100, what that's going to do is it's going to take the decimal that's here on this number and just move it 2 places to the left. So we're going to get 67.5 is that number. 67.5 is 15% of 450. And I can verify that by simply doing this. If I take my calculator and go 67.5 divided by 450, if this is the same as 15%, this should be 0.15. And there it is. Okay, so that is correct. So down here, take a look at another one here. We're going to say what percentage of 48, what percentage is 48? My mistake. I really got to be careful with that. What percentage is 48 of 124? So in this case here, it's that percentage that I'm unaware of. So I don't know what that percentage is. This is my unknown, if you will. It's my x. But I know that it's 48. 48 is in the is spot. Out of 124 is equal to, I don't know what percentage it is out of 100. I don't know what that number is supposed to be. Okay, cross multiply. So I love this. 100 times 48 is just 4,800. Is equal to 124x. And so now what I will do is I'll take that 4,800 and I will divide that by 124. And when I do that, okay, and I did it over here in my calculator, and when I do that, I get 38.71. So let's just say 38.7 is equal to x. Well, that's my percent. Okay, that's the percentage that I was looking for here. Remember that number, the percentage that I'm looking for, was in the numerator. I had put the 100 in there already, so I've already dealt with that, what that means to be a percentage, that fractional part here. Cross multiply and divide, and then boom, I get my answer out of that. Okay, let's take a look at this one right here. Last thing we want to look at is 35 is 22% of what number? Well, see, now of what number? I don't know what goes in the of position here, so I know it's going to be 35 out of, I don't know. Put an X here. That is going to be 22% out of 100. So as long as you can get clear where you put those values here, this is where you put the is this number, out of this number is the percent, and then we plug in the over 100 because it is a percent here. Now cross multiply, so we're going to get 3,500 is equal to 22x, and then I'm going to divide by that 22, so it's going to be 3,500 divided by 22 is equal to x, and I'm just going to go to my calculator. Let my calculator tell me what that is. 3,500 divided by 22. Okay, and I get 159 is equal to x. So that's the number that I was looking for here. 35 over 159 should equal 22% or 0.22. Now let's take a quick look. 35 divided by 159. Now, when I grabbed that 159, there were some decimal places back there, but they were back a little bit. So I'm assuming this isn't going to be like perfectly 22%, but it should be really close. And yeah, look at that, 0.22. So remember, this is going to be the decimal form. If I want to convert that to a percentage, I simply move that decimal 2 to the right. And so that's that 22%. Now, there's a little bit extra there, but I already kind of knew that was going to be the case. So anyway, I hope that gives you guys some idea, or starts to remind you of some of the work that you've done with fractions, ratios, and percentages.